All right, class. Today we're going to talk about chapter 13. So basically, initially I decided I should make two videos for chapter 13, which should be considered for July 18 and 19 class. But now I changed my mind, so I decided that I will only make one video for chapter 13, and you can think about this is the class for July 18, so that one class, and also from your end, it's less pressure because you will only need to send participation email for only one class, July 18. So there should not be any lectures, there should not be any class for July 19. Okay, good. And officially, this should be the last lecture videos. Okay, so I wish you all the best. Good luck for your future career and for future advice, suggestion. If you want to talk to me, feel free to shoot me an email. Okay, so let's start chapter 13. So in this class, we'll try to go over different topics. So we'll try to talk about expected return and risk, and then we'll try to talk about risk in great details. Okay, and we'll also try to talk about how to estimate required return for stock, which is based on CAPM model. If you can remember, on the stock valuation chapter, we actually decided that required return is given, right? So what you need to do is predict dividend, and then required return is given. In this class, we'll try to understand or try to know how to calculate required return for stock. So let's get started. Chapter 13, expected return. So when you talk about return, you have to be careful. So when you talk about return, you can think about return could be two types: actual, expected. Now let's go back to the timeline. So let's draw the timeline here. So let's say this is here, okay? And let's say this is 0, means today. That means 1 year ago, 2 years ago, 3 years ago, right? And let's say 1 year ahead, 2 years ahead, 3 years ahead, 4 years ahead, right? So this is today. Now, sitting today, if we want to think about any investment we made in the past and generated the return over this last 3 years, we are talking about actual or realized return. We already realized this return, okay? And we know this information for certainty because this has already happened, already occurred. We know this information, how much return is generated. Now, sitting today, so this is basically, you can think about realized. Now, sitting today, if we talk about tomorrow, that we want to make an investments tomorrow, we don't know really for 100% certain what is going to be tomorrow, right? Can you tell me, is it going to rain tomorrow? Is it going to be very sunny tomorrow? Is it going to be, I don't know, cold, hot, windy? We cannot predict 100% certain, but we can make an estimate that, okay, there is a high probability because it is around June or July, there is a high probability tomorrow will be hot than cold, right? Because it's midsummer. So we can make an estimate. So when we talk about tomorrow, we try to predict about tomorrow, we are talking about expected return, right? So when you say expected, you're talking about tomorrow. When you say realized, you're talking about past, yesterday, okay? Now, when you try to talk about expected return or risk, and we have to make basically estimate. We have to make different condition that tomorrow economy could be in a very good condition, or tomorrow economy will be due on an average, or tomorrow economy will be in a very poor condition. So we have to talk about tomorrow in terms of good, bad, poor, very poor, different state. And we have to identify what is the probability of the economy to be on that state. So let's say right now, hypothetically, we know that economy is a kind of a recession, right? So we can think about in the next 6 months, economy should not do well. So we can say that the probability of economy in a bad situation tomorrow is high, right? Rather than the probability that economy will do very, very well tomorrow, right? So to think about what should be the different state of economy or different state of the business tomorrow, and what is the probability of that specific state, right? After we determine the specific probability, then we have to determine in different state, what should be the return of my business, of my stock, of my investments. If the economy is doing well, we can expect my business, my stock will do well too, generate high return. Economy in average condition, we can expect the business will do on an average. Economy is a poor condition, you can expect that my business can make losses, okay? So in that case, we can say that this is the probability of boom, which is above average growth, 0.3 or 30%, normal 0.5 or 50%, recession, we don't know. So thing is that from your statistics class, I believe that you guys should have learned the probability of an event, if we sum them up, should be equal to 1. So basically, if you're thinking about tomorrow, the probability could be boom, normal, recession, and the sum of all these three events, what is the probability of an economy tomorrow is basically 1. In that case, these two consist of 0.8 to 80%, this should be 20% or 0.2 or 20%. So basically, if we say that, what is the probability of tomorrow? 3 different states, and this is the entire universe. Probability of an event, the entire event is basically 1 or 100%. Now, one caution, when you are trying to work with expected return or expected risk, I always recommend when you're doing calculation, do it in terms of decimal values, not percentage values. So 0.3 means 30%, so don't do 30, do 0.3. 0.15 means 15%, don't do 15, do 0.15, okay? So I always recommend when you're doing the calculation on the calculator, do it in the decimal term, not the percentage term. Now, this is the formula for expected return, okay? So summation of PI times RI. Let me explain what does it mean. This is a statistical sign. This is called summation, okay? Summation of independent events, different events, okay? And this is P, this is R, okay? So now this P means P of boom, P of normal, P of recession, probability of boom, normal, recession, 0.3, 0.5, 0.2, okay? Return of that stock I, this is my stock C, this is my stock T, okay? So basically this equation is trying to tell you probability of one event, which is, let's say, boom, times the return of your specific stock on that probability, which is 0.15. Summation means plus, plus, plus. So plus probability of normal economy times this return. Probability of recession economy times this return. And if you sum these three events all together, you will get the expected return of stock C tomorrow. So let's do this calculation by hand. So basically on the slide, I actually calculated everything step by step. So do this process, okay, step by step. I strongly recommend that. But now I'm showing it step by step by hand so that you can do it in calculator pretty easily. So I already copied the information, probability. So as I said, if this two is 0.8, then this should be 0.2, right? Because that sum should be 0.1 or 100%. You can see here, 0.1 or 100%, okay? Now let's do with expected return, okay? Expected return, okay, expected return for stock C. Let's do this way, okay? So the formula is, I believe you guys know that P times R, right? So probability times R of specific event. So in that case, probability of specific state of economy times return of your stock. So now we're doing C. So return of stock C on that economy, right? Make sense? Now if you drag, you can see that, right? Now summation of, that means sum of this, summation of probability times return of this event. So sum should be make sense? So my recommendation, when you're doing the raw calculation, always do in terms of decimal values, not percentage. This is percentage value. Don't do percentage. do decimal, okay? But when you are giving me the final results, either do 4 decimal here or do percentage, 9.90 percentage. So when you're doing the calculations, 9.90 percentage. When you're doing the calculation, make sure you are doing at least 4 decimal points. That's the standard in finance. And when I'm done with the calculations, you're giving me the final results. If you're doing me the decimal results, completely fine. Give me 4 decimals, up to 4 decimal points. If you're giving me percentage, give me up to 2 decimal, okay? Now let's do same way, expected return of RT. Same thing. So basically, probability times, oh, I misjudged. Probability times return of stock T on that. Drag. No, same things. Did you see that? And then 17.7. Makes sense? This is the expected return. So I actually calculated everything here. So you guys can do it by your hand. It's easy, just basic calculation. Now, this is the formula for expected risk, okay? This is the formula for expected risk. This is the same PI, which is probability of different state of economy. This is RI, so return on different state of economy, this. Now, this is not an I. If you look at it, there's no I. This is expected return. This is a constant value. So these will vary in different state of economy, but this will not. This is a constant return of your stock. So expected return is basically 9.99 for returns stock C, 17.7 for stock T. So now if you want to calculate, I have given you the calculation here, but I'm showing you on Excel step by step. If you want to calculate, so now we are doing basically expected risk, okay? So I'm going to talk about in details expected risk. What does it mean by expected risk in shortly, but let's just talk about it in terms of notation. So sigma square is basically known as variance, VAR variance. So basically variance are sigma square, okay? Make sense? Sigma square means variance. When I say sigma square, that means variance, okay? If we go to the slide, this is the formula for the variance. I'm going to explain variance versus sigma. What does it mean? Let's just follow step by step, okay? So variance means PI times RI minus expected return square. So if you look here, your first job is, we're talking about only stock C. We'll do T later, stock C. This is your RI minus, always when your calculation, decimal values, not percentage. Right? This is the very last part, times probability. In a set bed, I'll tell you, do this here, that here. Make sense? We're only talking about stock C. So in different state of economy, boom, average recession, state of economy, probably your return minus expected return. So in different state of economy, your return is this column, okay, minus, this is fixed, okay, this is fixed, square times probability. Now here again, different state of economy, your return minus, this is fixed, this is constant every time. 2. Oops. So this minus this 2 times probability. Makes sense? Again, your return minus this. So I have to make one more bracket. probability, right? So probability. If you look carefully, return of that state of economy minus expected return constant for all, square the term times the probability, okay? So, and make it 4-digit. And I'm giving you the calculation here. So you return 0.15 minus expected return, square the term times probability, okay? And 3 different state of economy. So now I'm summing it, okay? So this is variance. This is the variance, okay? Now, when you talk about risk, variance is not the risk. Your risk is sigma. Sigma is basically if you square root your variance, square root the variance. This is your sigma. So basically now you can be thinking of how can you do it on the calculator. So this equation is basically similar, right? This calculation is basically similar. So basically, this is basically similar calculation because you can plug in the number here, and then square the term times whatever the number. Now this is the square root, okay? So let's say 0.0008 square, 0.0283, okay? Or you can do this way. Just take this value, okay? Variance term. 0.0020. Did you see that? This is the value, right? So basically, if I make it 4-digit, so this is the variance term, okay? So now you can think about that, Professor, this is little different. I know this is a little different because of different decimal digits, because we are doing it in Excel. Excel is talking about actually 20, 30, 40 decimal points after the decimal, right? But here we are only doing 4 decimal points, but pretty close, 0.045. Now 0.0447, pretty close value, okay? That's fine. Now we did, this is variance, this is standard deviation. Do same thing for RT. So your specific return on that state of economy minus your expected return square times probability, okay? Similar way. Specific return on the economy minus expected return. Oh, I think I did one more. So let's see the formula. Okay. Now, again, this is variance, okay? This is variance. And this is standard deviation. So when we talk about risk, standard deviation, but the problem is you cannot calculate variance without calculating its standard. Sorry, you cannot calculate standard deviation without calculating variance, because it's a step-by-step process, okay? So if you have to go to the second floor, you have to go to the first floor first, right? So for calculating a standard deviation, variance is the first floor. So that's why you need to calculate the variance first, then standard deviation. But risk is basically standard deviation, okay? Now, so far we did expected return, expected risk, and I strongly recommend calculate that. Now, quickly on the homework. So I want you guys to do that. I already shown you how to do that, but do step by step and show the calculation in your homework 3, okay? Now we're moving on. So far we learned what? Total risk, right? So now we learned risk. So basically, total risk has 2 components, okay? Now, total risk, when you say total risk, it's denoted by sigma, standard deviation sigma. Now we can talk about what is sigma. This is a statistical sign. You can see this. This is the notation for sigma. Statistical sign or notation for sigma. Now it has two components. Total risk denoted by sigma. So let's go here. So total risk is denoted by, let's see if I can find the sigma sign or not. Let's see. Yes, I got it. Sigma, right, has two components. Systematic risk, and unsystematic risk. Systematic, unsystematic risk. So systematic risk is basically denoted by beta. So this is the notation, beta. So now this systematic and unsystematic risk has so many different names. So systematic risk, if you want to talk about systematic risk, this risk is also known as market risk, also known as undiversifiable risk. Okay. So you can think about this is a kind of risk you should not be able to diversify. You have to accept this risk. You have to tolerate this risk. And that's why you should get the compensation for this risk only. If you make an investment and that investment has systematic risk in it, you should get the compensation from the last class. If you can remember, on top of the risks we read, you should earn the risk premium if there's a risk in it. So the risk premium you are getting basically for this one. Market risk, undiversified risk, sometimes it's known as economy-wide risk, a lot of different names. One example, you can think about, so when we say systematic risk, you can think about, let's say, interest rate went up, right? In recent time, if you look, federal announcements that keep increasing the interest rate, right? So this is a systematic risk for the company. Because if interest is going up, it's expensive for all the company to borrow, and it's expensive for company to make additional investments. This is a systematic risk for the companies, and systematic risk is known as this is the risk for everyone. Like all the business in the economy will suffer for that risk. So that's why it is not diversifiable. So if you choose investment A rather than investment B, you should not be able to skip systematic risk. There is no way you should be able to skip the systematic risk. That's why you get the risk premium for that. Now, unsystematic risk, it also have a lot of different names. This is sometimes called diversifiable risk, sometimes called firm-specific risk, sometimes called asset-specific risk. Now, this is a kind of risk. If you want, you can diversify. So let's say there is a labor strike. There's a labor strike in any corporations, and that labor strike is very specific to that corporation. You can skip that risk by do not invest on that company. Just skip investing on that company. Right? And you can think about last year, there was a lot of chip shortage on the automobile company, right? So there is a shock on their business because of chip shortage, but this is not a problem for Walmart. This is not a problem for maybe a restaurants because they have no issue with the chip shortage. So this is not an economy-wide risk. This is not a market risk. So you can diversify. Now, that's why there is a topic called diversification. So if we go to the slide, go down. So there is a intentionally skipped some topics from here because the reason is all these topics, if you take finance as a major, you learn from the investment class. Okay, that's why it's intentionally skip those portfolio return, portfolio variance, all these things. Okay, so I'm talking about systematic here, unsystematic here, know the definition, know some example, and know the notation too. Now we're talking about diversification. So when you say diversification, that means if you want to invest your money, don't invest your money on one stock, rather split that money into different companies. So when you say different company, it doesn't mean only buy few tech companies because they're from same industry. They will suffer the same risk. So when you say different company, that means different company from different industry doing different business. Let's put some of your money in, let's say, electric vehicle company. Let's put some of your money, let's say, retailer. Let's put some of your money, let's say, bank. Let's put some of your money, let's say, tech companies, like chip manufacturer. Let's put some of your money, what else, like consumer discretionary. So something like that. Let's put some of your money on pharma. So this is diversification. But if you say, I bought 20 stocks from restaurants, or you can say entertainment industry like cruise, restaurants, whatever, resorts, this is not diversification. But if you remember, during COVID, this is the industry mostly affected. Okay, but during COVID, pharma industry, retailer industry, they do not most affected a lot. So diversification means put your money in so many different stocks who are doing different businesses. Okay, and if you can diversify, that principle of diversification is that if you can diversify, you should be able to diversify your unsystematic risk. Unsystematic risk. If you put your money in so many different stocks, you can eliminate the unsystematic component of your risk. Okay, and by doing so, you're only taking the systematic risk, and for that risk, you're getting the compensation. Now, if you look here, if you invest in one stock, you can see that your total risk is that much. Now, if you are putting your money in so many different stocks from so many different industry doing so many different business, you can see that your risk is coming down. And you're only the diversifiable or unsystematic risk is going down. Your systematic risk is still the fix. You should not be able to diversify the systematic risk. You should be getting the compensation for taking the systematic risk. But if you're putting your money in different stocks, you're actually diversifying your unsystematic risk, because you will never get compensation for unsystematic risk. Okay, so that's why when you're making investments, make sure you diversify your portfolio. So we talked about that. So just go over these slides. You will learn a little bit more. Okay, now we're going to come over here a little bit shortly. So far, we learn expected return, expected risk. We learn total risk denoted by sigma, that has systematic and unsystematic component. We'll talk about systematic component denoted by beta, and unsystematic component definition, example. And be careful, systematic component of the risk is only compensated, not the unsystematic component. Now, if you look at this slide, two different stocks, this has lower total risk, this has higher total risk. But if you look carefully, this has higher systematic risk, this has lower systematic risk. In that case, if you're thinking about compensation for taking risk, this will get more compensation or more return because it has higher systematic risk than this one. Make sense? Okay. Now let's talk about a little bit CAPM and beta. So what is CAPM? You can think about CAPM means capital asset pricing model. So if you want to invest in any stock, your required return or expected return should be a function of risk-free rate plus beta times expected return on market minus risk-free rate. Now be careful. This first part is known as expected or required return on your investments. You can invest in stock A, stock B, whatever. Okay. And second part, this is known as, sorry, okay, I know the problem. So risk rate. Okay. Now this part, This is basically a proxy or measurement of your systematic risk of your investment. Now, I'm not telling you how to measure this risk in this class. I'm keeping it for investment class, but just assume that the value of beta measures the systematic risk of your investments. And we're going to talk about what could be the prospective value and how to interpret, okay? Now, this part only is expected return on market. Expected return on market, okay? Now, there's a difference between this part and this entire area. This is not expected return on market. Expected return on market is basically this one. But if you look carefully, I'm doing expected return on market minus risk-free rate. So this is basically market risk-free. Now, one of the things you guys always make mistakes. If I said market risk premium, so risk-free rate is already adjusted for. So when you have market risk premium, multiply this with beta only, okay? But if I give you expected return on market, then deduct the risk-free rate first, calculate the market risk premium, then multiply with beta, okay? So be sure to make the difference between this area and this entire area. So look carefully on the problem, what is given. Now, we know that according to capital asset pricing model, if you want to calculate the expected return or required return on the market, we have to be careful, okay? Because it's a function of risk-free rate plus systematic risk measure beta times market risk premium. Market risk premium is the entire area, okay? Sorry, from here, market risk premium is basically this entire area. If on the test market risk premium is given, just multiply with beta. But if on the test only expected return on market is given, deduct the risk-free rate first, then multiply with the beta, okay? As I said, beta means systematic risk proxy. Beta could take value from 0 to anywhere, okay? So when beta is 0, what is the implication? So beta basically tells you how risky your investment is as compared to the market. I'm not going to, we are not going over how to calculate beta, but I'm just trying to give you some hints. So the formula of beta is basically trying to tell you how risky your investment is as compared to market, okay? When beta is 0, it is telling you your investment has no risk, no systematic risk as compared to the market. So let's say I'm talking about investing in treasury. From the last lecture, you know that treasury bills is a risk-free instrument. There is no systematic risk in it, right? So that means the beta for treasury bills should be 0, okay? Treasury bill should be 0. Make sense? Now, if the beta value is more than 0, less than 1, more than 0, less than 1, that means your investment is less systematic risky as compared to the market, or your investment has less systematic risk as compared to the market. If your beta has, so I'm talking about this one, if your beta is less than 1, that means asset has, sorry, this is less than 1, I'm sorry. If beta is less than 1, your asset has less systematic risk than the market. If your beta has exactly 1 value, beta is equal to 1, that means your investment has exactly the same systematic risk like the overall market. So that's why beta 1 means market. When we talk about the beta of the market, it's the overall market. So beta of 1 is overall market. So when we talk about beta is equal to 1, we're actually talking to beta of the market. Market has a beta of 1. If your asset has beta of 1, that means your asset has almost similar systemic risk as compared to market. If your asset has a beta of more than 1, that means your asset has more systemic risk than the market. So beta 0 means there is no systemic risk. We're talking about treasury bills. Beta less than 1, more than 0 means your asset has less than systemic risk than the market. Beta equals to 1, equal systemic risk of the market. Beta equals to more than 1, more systemic risk than the market. Makes sense so far? We have gone through this. We're not talking about portfolio. Then let's talk about a little bit how to calculate CAPM, right? So let's say 3 different security, right? 3 different beta, 1.685, 0.195, blah, blah, blah. You can say that this stock has less systematic risk than the market, right? Stock KO, okay? Stock C has way more systematic risk than the market. Stock INTC, which is Intel, has little more systematic risk than the market. Stock BP, I think maybe British Petroleum, has more systematic risk than the market. Now, from the formula, this value is same for whatever security you're using, because risk-free rate is the rate on treasury bills. Doesn't matter, you're talking about stock K, stock C, whatever. On the CAPM equation, RF should be the same value. This should be the same value because we're talking about the expected return on the market. This should be the same value because we're talking about the risk-free rate, right? The only changing factor of calculating the expected return of different stock is basically the beta of your stock. So basically, if you're investing in stock A versus B, risk-free rate is the same, expected return the same. But depending on the risk characteristics of your investments, your expected return will go up and down, and the changing factor is your beta. If you go here, consider the beta for each asset given earlier. We know that this is the beta. Risk-free rate 3.15%. Market risk premium, be careful, market risk premium, which is the entire area that's given. So do not deduct risk-free rate again. Market risk premium is 7.5%. What is the expected return for each stock? We're using same risk-free rate, same risk-free rate, same risk-free rate, okay? But only the beta is changing, and same risk premium, market risk premium. Now this is the expected return or required return on stock C, stock KO, stock INTC, stock BP. Now if you rank these stocks, you can see that stock KO has the lowest expected return because of the lowest systematic risk. Stock C has the highest stock expected return because of the highest systematic risk. Now this is all so far from this class. I'll briefly go over the homework. When we are done, we are finishing all the lectures for this class. So we have done these today on the class. Results is on the slide. Differentiate between total systematic and unsystematic risk. So you can think about the total risk is the total variation in the return data or in the business operation. Systematic risk is the unavoidable component or undiversifiable component of the total risk. Unsystematic risk is the diversifiable one. Interpret the beta. What is beta? Beta is a proxy for systematic risk, and that tells you how risky your asset is as compared to the market, right? Beta means 0, no systematic risk. Beta means less than 1, less systematic risk than the market, equal to 1, equal systematic risk of the market, more than 1, more systematic risk than the market. That's it. So that's all. I wish you all the best for your upcoming fall semesters and your upcoming career, okay? All the best.